In this first lesson of Calculus 3, we're going to be reviewing vectors in 2D, 3D, and the unit vector. This first vector, u, is going to be 3 in the x direction and 1 in the y direction. If we move it over to the right here, the component form looks like this. We're going to have a second vector in the third quadrant, -2 in the x, -3 in the y, and the component form is going to be -2i hat plus -3j hat. Now, if we add these two vectors together, we can do it with the component form or using the tip to tail method. They both get the same result. U plus v gives us 1 in the x direction and -2 in the y direction. Same result, both methods. Next, we're going to be exploring the unit vector. The unit vector is a vector in the same direction as a given vector, but it only has a magnitude of 1. I've drawn a unit circle to emphasize that point. The white vector will always be touching the unit circle. The equation for the unit vector is the given vector divided by its magnitude. So in this case, it's 3i hat plus 1j hat over the square root of 3 squared plus 1 squared, similar to Pythagorean theorem. The result is 0.95 I hat plus 0.32 j hat. If we're to shift the pink vector to the left, you'll notice that the pink vector's length is shrinking while the white vector's is staying the exact same length, but it's changing because it's following the pink direction. That's an example of the unit vector always staying at magnitude 1. Now it's time to move on to the Calculus 3 part, 3 dimensions. On the right, you have our 3D view. On the left, you have a top-down approach of that 3D view. So we're looking directly from above it. Left is the xy plane. If we draw the same vector on both sides, this is another vector called u. This is what it would look like. The right is the 3D, the left is directly looking down on top of it. This vector has 2 in the x direction, -3 in the y direction, and +2 in the z direction. You'll notice on the left that you don't see any yellow line because you're looking directly down on top of it. We're going to look at the unit vector again. I've drawn a sphere of radius 1 on the screen. On the left, it looks like a circle because it's top-down view. We're just viewing the cross-section. On the right, it looks like a sphere because that's what it is. Now, when we draw this unit vector, what you'll notice is that on the left, it doesn't reach the edge of the sphere. Take a moment now to try to guess why that is. The reason is because this vector is in 3 dimensions, but we're only looking at it in 2 dimensions. So this white arrow on the left here is touching the edge of the sphere, but the point of contact is above the xy plane, so it doesn't look like it's touching the edge of the circle. Now, I'm going to shift the vector to -2 in the x direction. Watch each component to see how it reacts. Only the x direction was moved. The y and z directions were unchanged. If you can visualize that in both the xy plane and in a 3D vector, that'll help you with understanding calculus. Feel free to play it back a few times to really get a handle on what just happened. This is the end of the first lesson. We introduced 2 major equations. The first is the component vector form. In 3 dimensions, this is going to be a I hat representing x, b j hat representing y, and c k hat representing z. The second is the unit vector equation. This is going to be the vector over its magnitude, which is going to be equal to the component vector form of that vector divided by the Pythagorean theorem or the distance equation for 3 dimensions. Thanks for watching. Leave a thumbs up if it was helpful, and subscribe if you want to see more math videos. See you in the next lesson.